Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. For the overhanging beam, determine letter A, the value of EI delta under the 24 kilonewton load, and letter B, the maximum value of EI delta between the supports. For letter B, the maximum value of EI delta, of course, where the slope or EI prime is 0. And because of this couple here, it is expected that the maximum deflection, so its effect is to move the maximum deflection somewhere here. So the location of maximum deflection is less than 3. But let's solve for the reactions first. R1, that's R2. Moment at 2 is 0, equals R1 times 6 plus 24 minus 24 times 3. So R sub 1 is equal to 8 kilonewtons. So summation forces Y, if that is 8, then R2 should be 24 minus 8, so 16. So put the reactions. R sub 2 is 16. Then let's section up to this part. Then distance x from this origin here. So therefore, the differential equation EI y double prime is equal to 8x minus 24 times quantity x minus 3. Then plus R2, 16 times this moment arm, x minus 6. Integrating EI y prime equals 4x squared plus 8 quantity x minus 6 squared minus 12 quantity x minus 3 square plus c sub 1. There is c sub 1 again. There's slope here, but there is no c sub 2. Integrating again, EIY equals 4 thirds x cubed plus 8 thirds quantity x minus 6 cubed minus 4 quantity x minus 3 cubed plus c sub 1x. There's no c sub 2. Then when x is 6, y is 0. So let's evaluate c sub 1. 0 equals 4 thirds 6 cubed. This is 0 minus 4 times 3 cubed plus c sub 1 times 6. So c sub 1 is negative 30. Then substitute here. EI delta at 3 is set x is 3. 4 thirds of 3 squared. This is ignored, negative. This is 0. Then minus 30 times 3. So there are two terms ignored because it's either negative or 0 inside the parentheses. So delta 3 EI delta 3 is equal to, under the 24 kilonewton load, negative 54 kilonewton meter cube. So that means it's downward. For the maximum deflection, we set y prime 0. Remember, for maximum deflection, the slope at that elastic curve is horizontal or 0. So 0, y prime is 4x squared plus 8 quantity x minus 6 squared minus 12 quantity x minus 3 squared plus c sub 1, which is negative 30. So if x should be less than 3, should be here, because when x is exactly 3, this is 36, and 36 is 4 times 3 squared is 36. This is ignored, and compared to minus 30, so it's positive. So that means x should be less than 3, because it will not be 0 if x is greater than 3, because this is ignored and this becomes negative also. So x should be less than 3, comparing these two terms here. So it means that we have to ignore the second and the third term, because when x is less than 3, this is negative and this is negative also. Not the quantity square, but the value inside the parentheses, negative. So 0 equals 4x squared minus 30. Solving for x, x is 0.5 square root of 30 to be exact. Then substitute into EIY and set x equals 0.5 square root of 30, and that corresponds to the maximum deflection. So EI delta max equals 4/3 quantity 0.5 square root of 30 cube, ignored, then minus 30 times 0.5 square root of 30. So EI delta max is negative 54.77 kilonewton meter cube, and that's negative, so downward. That's why it's greater than this in magnitude, because this is exactly when x is under the 24 kilonewton load, so the maximum deflection is greater than this in value.